Welcome to this demonstration speech. My name is Jesus Luna. Today I'll show you how to take basic derivatives. Well, first I'll introduce the concept and some of its real-life applications. Following there, I'll introduce some of the basic rules and theorems to have a successful introduction to this theme. Okay, so first you might ask yourself, what's a derivative? Well, it is an expression of the rate of change of a function. So as we see in here, we have the function 2x squared plus 4x minus 2, which is represented by the color red, as we see in this graph. And then we have its derivative, that is 4x plus 4. So as we see in here, as the values on the graph are descending, the value of the derivative is negative, till the point in which it changes to ascension, meaning that its values of the derivative will be positive, because the values on the function or the rate of change goes from a descending or negative to a positive and ascending. So when will you use them? Well, these are mainly used to calculate the profit and loss in business and in multiple physics problems if you're interested in them. So now I'll introduce you to some basic ideas and show you how to easily calculate derivatives. So in order to calculate derivatives for natural numbers, in this case having the function 4x, the derivative of a natural number will always be 0. So the derivative in this case would be 0. For linear functions, in this case a function that equals f of x that equals 4x, its derivative will always be just the number in front of x. In this case, its derivative will be 4. Now, for some polynomial functions, if we have the function 2x squared, you need to multiply first by the exponent to the number on the front, if there is one, and subtract 1 from the exponent. So in this case, we multiply the exponent 2 per the coefficient, which is 2, we get 4. Then we subtract 1 from the exponent, which will give us 1, which is mostly not represented when taking into account the representation of a function. So its derivative would be 4x. Now a special when it's e to the x, this function, it's always equal to itself. So its derivative would be just e to the x. Now, some basic derivatives. A rule is that when a function containing addition or subtraction is derived, the signs are preserved. So you have a function 12x cubed plus 6x. If we derive it, we'll get 36x squared, which would be just 3 per 12, 36 minus a 1 on the 3, 36x squared. Then we preserve the sign, plus, and we get the derivative of 6x, which would be just 6 because it's in front of the x. Now for the next function, we have 3x squared minus x minus 1. If we try to take its derivative, we first preserve the signs, and then we proceed to do the exponent rule, in which we multiply exponent per the coefficient, 6x, and we subtract 1 from the exponent, which would be just 1, 6x. We get minus the derivative of x, which would be just 1, and we get the derivative of the natural number 1, which would be 0. This will give us as a final product that the derivative of f of x would be 6x minus 1. Well, that's all for my part. I hope you find this enjoyable and easy for you in order to understand this theme and help you with calc. So thanks for hearing and watching this video.